guys! So today we're going to be looking at Chapter 3, Section 5, Solving Nonlinear Systems, Part 1. So, a nonlinear equation usually shows two equations, and at least one of the equations is going to be nonlinear, which means that, for example, let's say you have two equations given to you. Over here, you can tell that this one, because of the x to the power 2, this is not a linear equation. This would be a parabola if I were to graph it. So we would consider this to be nonlinear. And then over here on the right side, we do have a linear equation since it just gives us the value of x. So when two equations are graphed and one of them is nonlinear, then the graph can intersect 0, 1, or 2 points. So for example, you see here in this image, we have two images or two graphs being shown. One of them is nonlinear, it's a parabola, and the other one is a line. In this case, they're not intersecting with each other. Like let's say if you had it on a graph, it's showing that either way, it would never intersect. And so because of that, we would say this is not a solution. There's no solutions provided here where both of them are intersecting. In the cases where, let's say, you have a line and it's intersecting at specifically the vertex of the parabola, then we can say here, okay, we do have one solution specifically. The most that you can have is two solutions because on a parabola, there's only one or like 2 points that could ever actually intersect with it. You can't get 3. If you had 3, it would have to be like a graph that looks kind of like more like this, and then you have like a line going through it to get 1, 2, 3 points. But because there's only one hump that's being shown, then you're only going to get 2 points at most, which also means that you would only get 2 solutions. And the same goes for if you have graphs where you have 2 parabolas instead. In the case where they're both not touching each other, we would have to say there's no solution. In the case where they're intersecting at the vertex, we would say that there's one solution. And if they're intersecting somewhere that's just not the vertex, you're going to get 2 solutions. And so today what we're going to be determining is, do we have a solution? Do we not have a solution? Do we have 2 solutions? We'll be using certain ways to solve that. So first type of way that we could solve nonlinear systems is by graphing them out. So let's say you have these two equations here. You have y equaling to x to the power 2 minus 2x minus 1 and y equaling to negative 2x minus 1. First thing that I want to do is graph out both equations onto the graph here. So if you remember, graphing out y equaling to x to the power of 2 minus 2x minus 1, when I'm graphing out a parabola, I need to identify what the axis of symmetry is. So I still need to use the formula x equaling to negative b over 2a. And so my b value is going to be a negative 2. So I get here negative, comma, negative 2. And that's going to be over 2 times positive 1. And that just equals to positive 1. Once I get my x value, I can plug it into my equation. So since x equals to 1, then I can plug it into the x to the power 2 minus 2x minus 1. So I get 1 to the power of 2 minus 2 times 1 minus 1. And then I'm left with 1 minus 2 minus 1. That just equals to negative 2. So that would be my y value. So for my vertex, we get 1 comma negative 2. Cool. So let me just plot that on the graph here. Going to 1 all the way down to negative 2, we get this point right here. 1 comma negative 2. Okay, so once I have my first plot, I just need to find 2 or 3 points that are to the left of this 1 value. So let's look at 0, because that's the point that's to the left of 1. If I look at 0, I don't know how high or low I have to go, so I need to plug it in. So we can always do a table first. This will be my x values, this will be my y values. And I'll just find all the points that are to the left of this parabola. So I'll do 0, -1, -2, and I think that's good enough. So we'll do 0, -1, and -2. And I did it the wrong way. -2 is smaller, -1, and 0. So let me just plug it in real quick. When I plug it into the equation, I get -2 to the power of 2 minus 2 times -2 minus 1, that equals to 7. Then -1 to the power of 2 minus 2 times -1 minus 1, that just equals to positive 2. And 0 to the power of 2, -2 times 0 minus 1, that just equals to -1. So I'm just going to plot these real quick onto the graph. On the other side, I have 0, -1. And then I have here -1 going up to 2. And then the last one is -2 going all the way up to 7. So I just have to copy the same heights on the other side. So the point next to the graph, or like the vertex, would be this point. Then the next one would be over here. Last one would be the one right next to it, which is right here. So if I were to draw my parabola, I know that I would get something that looks like this. Cool. Okay, so next step, we need to graph out our linear equation now. Our linear equation was y equals to -2x minus 1. And so all I need to do is identify what my slope is and my y-intercept. So underneath, I'll put down the equation y equaling to mx plus b. My m is equal to -2, and my b is equal to -1. So I know that my slope is going to be m equaling to -2. If I want to change that into a fraction, that would just be -2/1. My y-intercept, which is b, is equal to -1. So I know that right here, for y-intercepts, x always has to equal to 0, and I'm left with -1. So I can just plot that down. So we have here 0 going all the way down to -1, which automatically gives us our equation. But again, if you want to continue graphing it, you can. Right here, I'm going to graph this out. We're going to go down 2 points. And then we're going 1 point to the right. And then we're just going to continue doing that. So going down 2 points, because it tells us to go down 2 points, and then go to the right 2 points. 1, 2, and 1. So we get a line that looks like this. And it's at the very edge of the graph, or of that parabola. So we know for sure that the graph and the linear equation and the parabola, they definitely intersect at 0, -1. So that would be our final answer. Our answer would be 0, -1. Done. Okay, so that's the first method, is solving by graphing. Second method that we're looking at is going to be solving a linear system by substitution. So let's say you're given these two equations. The first one is x to the power 2 plus x minus y equaling to negative 1. And the other linear equation is x plus y equaling to 4. Easiest way to do this is to start off by isolating your y value, because you do have two x values. So it just makes it easier if you substitute into the y value here. So I'm going to start off first by isolating my my y value from x plus y equaling to 4. I'm going to start off by subtracting x to both sides. And I'm left with y equaling to 4 minus x. So over here on the other side, with my x to the power 2 plus x minus y equaling to negative 1, all I'm going to do is plug the 4 minus x into the y value and just swap it. So we get here x to the power 2 plus x minus whatever this is, which is 4 minus x. And drop down the equal sign and the negative 1. Then I just need to start simplifying. So x to the power 2 plus x minus 4 plus x equals to negative 1. And then I get here x to the power 2 plus 2x minus 4 equaling to negative 1. And then I could also add 1 to both sides. And if I do that, I'm left with x to the power 2 plus 2x minus 3 equaling to 0. So from here, I want to determine if this is factorable first. If it's factorable, that would be the easier way of going about it. So I'll check using the cross method and seeing if there's any two numbers that can multiply to get multiply to get 1 times negative 3, multiply to get negative 3, and add to get positive 2. And I do know that we can use 3 and negative 1. Those two work. So when I do that, I get here x minus 1. Oops, actually I don't. What? X to the power 2 plus 3x minus 1x minus 3 is equal to 0. And then from here, I'm just going to factor out an x from the x squared and the 3. Then factor out a negative 1 from the x and the 3. When I do that, I'm left with x plus 3 times x minus 1 equaling to 0. And so I get two equations, x plus 3 equaling to 0 and x minus 1 equaling to 0. Solve it. Subtract by 3 on both sides. Add by 1 on both sides. And so my new solutions would be x is equal to negative 3 and x is equal to positive 1. Now, the really important part here is to not just stop here. This is not your solution. This is only a part of it. Because if you can remember, when we're looking for a solution, we're looking for that exact point that is being or identified as being intersected. So we're not only looking for our x value, but we're also looking for our y value too. So what I need to do now is plug in this x value into one of these two equations to identify what my y value is. So I can do that. I'll just choose the x plus y equaling to 4. That seems like an easier equation to plug it in. So let's start off first with the x equaling to negative 3. So I'll put here to the side. We're substituting x for negative 3 first. If I do that, I get here negative 3 plus y equaling to 4. Add 3 to both sides. Now I'm just left with y equaling to 7. So my first order pair is going to be negative 3, 7. The next one we have is x is equal to 1. When I plug it in, x plus y equaling to 4, I get x plus 1 equals to negative 4. Subtract by 1 on both sides. And when I do that, I get x equaling to positive 3. So I get the ordered pair 1, 3. So in this case, we got two solutions, which means that's probably one of the images where you have a parabola. And somehow in the graph, assuming probably it's going to go down this way, right here like this. One of the points is going to be negative 3, 7. And the other point that was intersecting the parabola was 1, 3. So in this case, we got the two solution type. So our two answers are shown right here. I'll put it right here. So answer is negative 3, 7 and I shouldn't put that press. And 1, 3. That would be my final answer. All right, last one that we're going to be looking at is the last method, which is solving a nonlinear system using the elimination method. So this one is not as complicated as it seems. Normally, you're going to have like a variable where you'll have just one y value or maybe possibly one x value. But in this case, you're going to see here that you have just one y value that you can automatically eliminate. And once you eliminate the y variable or the x variable, then it makes it so much easier to solve. So right here, if you have 2x to the power 2 minus 5x minus y, and this is over x to the power 2 plus 2x plus y, and this is equal to negative 2, this equals to 0. All I'm going to do is just combine it together, because automatically, if you notice here, if I combine it, that cancels out. So I'm left with 3x to the power 2 minus 3x equaling to negative 2. And so I can factor it out just like I did last time. If I factor this out, I would add 2 to both sides first. And when I do that, I'm left with 3x to the power 2 minus 3x plus 2 equaling to 0. So if I were to try using the x method here, it's not going to work. There are no variables that would work for this because this would turn into 6. This would be negative 3. There's no two numbers that would actually work with this. 2 times 3 doesn't work. 1 times 6 doesn't work. None of these will work. So because they won't be factored out properly, I have to use the quadratic formula. So x equals to negative b plus or minus square root b squared minus 4ac, and that's all dividing over 2a. So if I plug that in, my b value is negative 3. So I have here, comma, negative 3. Oh, actually, not just negative 3. Negative 3 plus or minus the square root of negative 3 to the power of 2 minus 4 times 3 times 2, all dividing over 2 times 3. So when I solve this, I get 3 plus or minus the square root of 9. This turns into negative 24. Oh, I made that way too long. Here, shrink it. Then this is all dividing over 6. So right here I get 3 plus or minus the square root of, I don't know what this is. 24, 9, 14, 1, 15. So we get here negative 15. And on the bottom, we have 6. Okay, so if you remember from the previous section, we said that this b squared minus 4ac determines if we have one solution. So I'll write it right here. Just a reminder. We said that if our b squared minus 4ac is bigger than 0, then that gives us 2 solutions. If we have b squared minus 4ac equaling to 0, we said that would be one solution only. And the last one that we did say was that if we have b squared minus 4ac being less than 0, so a negative number, we get no solutions. So if I were to look at my answer here, I see that I got a negative answer. So because I have a negative answer, that means that I'm not going to receive any solutions, no solutions. Which means that if we were to look at these two graphs, most likely they're looking something like this, where they're both going in opposite directions and will never intersect each other. Well, that's not what I wanted. Sad face. There you go. Yeah. So in this case, they're just never going to intersect each other, and so we are not going to get an ordered pair. So that's how we would leave our answer. Okay? So hopefully this helped. Good luck.